Good morning students, myself Badi Alekhyya, Assistant Professor, Department of Artificial Intelligence and Machine Learning, RMD Engineering College. Today we are going to discuss about the topic called clustering. So in the previous sections we already discussed that what are supervised learning algorithms and unsupervised learning algorithms. In supervised we discussed that different types of techniques, classification and regression. Under that classification and regression we solved different algorithms related to classification and regression. So the second type of learning we have unsupervised learning. There one of the important technique is clustering. So let us proceed with the slides. What is clustering? What is the role of clustering in unsupervised learning? So before that I just give an introduction what is unsupervised learning, then we in-depthly enter into the concept of clustering. So everybody are aware of that what is unsupervised learning in our initial classes. I am giving some data, but for that data I am not giving any labeling. If you observe these examples, different types of fruits are there, but I am not labeling that what is the object, what is that object is representing which type of fruit. That labeling is not done in this particular given data. So this type of learning we are called it as unsupervised learning. If you observe that some data we are going to represent without label and we are doing some operations to predict the output, we call it as unsupervised learning in simple words. So what are the different type of applications now? We are grouping the same data without any label, customer segmentation, image compressions, and bioinformatics. Like in these different types of application, to find out the important features, we are using unsupervised learning techniques. For example, if I am considering a raw data, in that raw data if I am extracting some features, for that based on the similarity of the features we are make it into groups. That groups are we are going to split that groups into classes or clusters. So here for the classes or clusters there is no supervision is needed to perform analysis on the given data. Just it is going to perform natural grouping mechanism. So aware of that what is clustering? Grouping of similar objects. Here we are going to group the similar objects into classes. What are the different types of applications? In Gini's expression data we are using in phase clustering. If you observe here, keyframe extraction. So the keyframe is extraction and it is going to find out phase, and it is going to find out the phase, and after extracting the features and make it as cluster. If I am going to take so many images of this person and make it as group, and that here if I am going to capture the three phases now, that phase 1 is make it as one cluster, and phase 2 is make it as another cluster, phase 3 is make it as another cluster. If the same image is getting into again that is moves to the cluster 1. Like that the grouping of similar objects will be performed in the phase clustering application. So these are the this is one of the examples of phase clustering, in which way it is going to group. So like if I am going to search any content in my browser, so for example if I am typing apples, apple is a fruit name, apples, it will display the fruits names, or otherwise it will display the name of the for mobile phone company, or otherwise it will give some information regarding company. That means it's going to embed it. That means it will group the data based on that keyword. Based on that keyword, whatever the relevant information is there, it is going to map it and display it on the screen. This is also a best example for clustering. So like Google News also, same thing we do for retrieving that information. Top stories we are going to consider in Google News. Same the same example. This is also one of the example for clustering. So finding, clustering, advertisers, keyword suggestions, performance advertisements, clustering in searching advertisement, also searching advertising. It's a it's useful for finding, is useful to map the keywords to get the relevant information. So search advertising is also a playing a very important role. It is one of the techniques which we followed under clustering. Issues for clustering. So what are the two things you have to store it in mind when you are designing any clustering? If you are going to group the similar objects together in a one class, in that class the distance between the one data point to the another data point should be less in the intra cluster, and when you are going to group the object into the another class, the distance between cluster one, no, the distance between from one cluster to another cluster, that means the inter cluster distance should be maximum. So these two things we have to maintain in your mind if you are designing a good clusters. And after that, some of the issues when we are going to face in when we are facing in clustering is where there is a confusion how many clusters we have to decide, how to fix a priority for the clusters. So different types, the what's 2 points I told now. So intra distance and inter distance, these two features we have to consider. How much of cluster, how many number of clusters, whether it is fixed or based on the situation we have to change. These are the issues for clustering. So we have different types of clusterings. Here K means clustering is there, K myriad clustering is there. These two clusters is based on partition technique. Hierarchical clustering is there based on the dendrograms techniques. That means we are going to represent the information in the form of tree structure. So like we are in K means partitioning clustering techniques, we are make it as groups of clusters. In hierarchical clustering, we are going to following the tree like dendrograms to classify the given data into different clusters. So there are one type of different types of the algorithms is there, agglomeratory, divisive. So this technique will follow. So the first technique will follows bottom up and the second technique will follows top down. So we are aware of the most well-known and popular clustering algorithms. This algorithm is based on distance. First of all, if you want to work with this algorithm, K means algorithm, we have to decide that how many number of centroids. We initially randomly we will assign the centroids in the given for the given data, and then only based on the results we are standardized that the centroid values for in the process of the K-means clustering technique. So in the given data, initially we can first step, initially we can choose randomly choose the centroid values. After choosing the centroid values, we assign points to the nearest center. So based on the centroid values, we are going to group that data points nearest to that centroid values. That will make that these data points belongs to this cluster, and based on the centroid values, if the centroid data points which is near to that centroid, that when we are going to consider it as make it as one class or clusters. So we can readjusting the centers based on the at one iteration we are going to change our centroid values, and we are going to readjusting the centroid values up to we are correctly classified how many which data points is belongs to which type of which data points are belongs to which cluster. We are going to readjusting our centroid values in the given data. So we are going to mostly we are assigning the points to the nearest center only. If no changes will done, we can stop the procedure. How do we do this procedure na? First, assigning cluster each example to the closest. Recalculate centroids as the mean points in the cluster. So if we are observing that things, initially I tell that randomly we can choose the closest centroid values. Based on that, we are going to calculate the mean of the points in a cluster. So iterate over each points, we are going to get the distance to the each cluster point, and we are assigning to the closest center. So hardy cluster. So again we are recalculating the centers as mean of the points in a cluster. We can repeat this procedure. What distance measure should we use here is we are using Euclidean distance. Euclidean distance we can use. In k-medioid technique we are using Manhattan distance. So this is the formula, everybody are aware of that. It's good for Euclidean distance. We already discussed this Euclidean distance in KNN also, k nearest neighbors. What is the formula for that? x2 minus x1 whole square plus y2 minus y1 whole square. So to calculate the distance between the data points, we are going to consider this measurement. So initially we see cluster centers and we are doing some fixed number of iterations if partitions are unchanged. So one step the partitions are same, and the another step also the same partitions range, the same partitions will be repeated. Now then we can stop the iterations and we can fix the cluster centers to make it into groups. Seed selection ideas. Initial centralize, already we discussed that. We are choosing the centroids of the given data randomly. This is the procedure, just for your understanding. So I told that initially we are selecting the randomly centroid values. Based on the centroid values we are going to calculate the distance. It will generating, we are going to choose that based on the generated values. We are grouping that if that value is nearer to the centroid, now we make it into that group of cluster. Like that we are repeating this procedure. This procedure is repeated until the iteration will provide the same results. Then we can stop choosing the centroid, then we finalize the centroid values and stops the iteration. Then decided that how many data point, which data points are belongs to which type of clusters. So imagine that if I am going to consider 3 clusters in my clustering, if I am going to consider that 2 data points belongs to first cluster and 3 data points belongs to second cluster and 3 data points belongs to third cluster. Now in my fourth iteration also the same sequence will be repeated. Then we can stop the procedure and conclude your final answer. So this is the procedure of implementing k-means clustering. That's all students regarding the implementation of k-means clustering. In the next sessions I am going to discuss the problems of how to implement the k-means clustering algorithm. The algorithm we are going to implement in a into problem. So that's all today. We are just understanding what is this unsupervised learning, what is the importance of clustering in unsupervised learning, what are the different types of applications supported by unsupervised learning, and among that we have different types of algorithms and under clustering, partitioning clustering and hierarchical clustering. In that partitioning clustering we discuss k-means clustering. So the k, when you are going to solve the k-means, when we are going to grouping the similar data into cluster by using the technique of k-means clustering, now you have to follow the steps. First you have to select initially selected centroids randomly. Based on the iterations we are going to choose the centroid values. So how to where you can stop the procedure now, where your values of the data points belongs to the clusters will not be changed, then you can stop the iteration and finalize your centroid values. This is the procedure for implementing k-means clustering algorithm. So here we are using some heuristic function to observe that sum of squares of methods. So then it is only used to calculate the distance between each data point and the closest centroid. Then only it is decided that if the distance between the centroid and the data point is less, means it is comes under that cluster. If it is more, means it belongs to another cluster. Like that we have to partitioning. So that's all for the today's section. Thank you students. I will meet with some other new concept in the